Header 1, December 25th. All right, let's do this. Target sum. Integer array, target sum. You'll want to build an expression out of nums by adding one of the symbols, plus or minus, before each integer in nums, and then concatenate all the integers. For example, if this, you can add a plus before 2 and a minus before 1 and concatenate them to build the expression. Return the number of different expressions that you can build, which evaluate to target. Okay, this is a 20, so it's going to be 2 to the n power. We're going to recursion. Basically, what we're going to do is, for each one, basically each one you can decide it's going to be a positive or negative, right? And then next one is also positive and negative, and then you just go through all different possibilities. Now, we don't have to go through all different possibilities because we can just use a bitmap, right? Bit manipulation. Because I know the length, right? So this is a 1, 2, 3, 4, 5. So the total number of possibilities is 2 to the 5, right? So that's 32 possibilities. And now we just go from 0, right, all the way to 30, okay, all the way to 31, I think, right? All the way to 31. So basically it's going to be all 0. Well, this is 0, 1, 2, 3, 4, 5. So basically it's 5 zeros, right? All the way down to 5, 1. And I can define 0 as a negative 1 and a 1 as a positive 1. So just go through this for each one. I will just multiply. If it's a 0, we'll multiply by minus 1. If it's a 1, we multiply by 1. And then we add them together to see if x is equal to the target. Okay, that shouldn't be hard. We should be able to get this one done in no time. In no time. All right, let's try this. I'd like to say this, right? And I'm going to say int rest is equal to 0. For I equal to 0, I smaller than n, I plus plus. Okay, and then we're going to say and do a private int compute. Okay, so we have a mask and we have the vector. Okay. While hold a second. For I equal to 0 smaller than nums loss. Oh. I smaller than n I plus plus. If mask and one left shift I, ooh, okie dokie, has to change this, n minus I probably one left shift one, hold on, one left shift 1, 2 minus 1, right? So if this is equal to 1, then sum plus equal to nums I, else sum plus equal minus equal to nums I, and now I return sum, I return rest sum, so it's no rest. Okay. Right, so just make sure this one's correct. Yep, I think this is right. And then we can say int sum equal to compute mask nums, right? If sum equal to target res plus plus. And then we'll return res. Alright, take a look. We did it pretty fast, so there's a chance that's not precise. No, it's not precise. Alright, let's see what went wrong. This is a mask. Oh, this is not right. It should be my bad. 1 left shift n minus 1. Int total possibility is 1 left shift n and 1, oh my goodness, n minus 1. Alright, so this should be total possibility. My bad, I completely forgot about this. That is very interesting. For 1, it should be, I think it should be small or equal to, oh, if it's small or equal to, then we can just do this. But it's probably still not right. Oh, I got one of them. The top. That is interesting. What do we get then? I don't want to debug yet, so let's just do cout. Minus 5, minus. Huh. All of them are negative. Oh, shoot. Shoot. It was my bad. It's not 1. Oh, we got a little little error here. (494) brute force, but use bit manipulation to iterate through all possible operator combinations. True to the end. Alright, I'll run this one more time. Actually, we can do, yeah, that's fine. Actually, it's not fine. I like to try a few things. Start from 0. Okay. 1, 2, 4, 5, 100. Yeah, looks about right. 2022 was the initial time when I tried this. Oh wow, negative 1,000. Oh, my bad. Ah, shoot. Okay, this is not expected. This is absolutely not expected. There we go. I was just a little bit error. I forgot to change some stuff. Okay, we got a TLE. That's also not expected. They started to call TLE on this. Huh. Interesting. I thought we can do it. Oh. That's now true. This is times n. That's why TLE'd. Because you have to go through this one more time. Okay. Didn't realize that. That's fine. Let's think. Let's think. We might have to do some memoization. Okay. This probably needs some memoization. Basically, we have a state, and we know the state. But if it's a state, you still need the index. So that's still on times 2 times n. Right? Because I have all different combinations initially, all their sums. And how many times they have appeared. Okay, if I have how many times they have appeared, like someone appeared this number of times, someone appeared this number of times. And then when you do this, you update all of them. Okay, maybe this will work. Yeah, because each one is just plus or minus, right? So you have a list of all possible that's original in there. And then you just go through them one by one, and each one just plus minus. And this one plus minus, this one plus minus, everyone plus minus. Right? So but that will be 2 to the n times n as well. Yeah, take too long. have different types, right? I thought that would be enough. How about we compute everything, and because the two adjacent one, I'm actually not quite sure. I just need to know which one changed. Right, I just need to know which position changed. So in this case, so if I do exclusive OR, then I have some position changed. Since I'm thinking, you get the sum, and then adjacent to, you compare which positions changed, and then just make modification for that position change. That's kind of another idea, right? But sometimes things change. Like you plus one, that's gonna be this. So it's like, right? So every single position has changed. So for those cases, you have to go through all the changed positions and make changes. But on average, right? Because the next one, yeah, if you think about it, let's say once you have go through, right? Once you have go through, you have this. Let's say I have gone through all different possibilities of this, right? Now you're adding this one, the new one coming in. I have all the combination of this already done. So, but you have to go through all of them, right? You have to go through all of them. I mean, if there's a lot of repeats, then the other method might be able to get it. Okay, so let's try another method. Not 100% sure that will be faster, but feels like it will be faster. So this method is also very straightforward. So we're gonna get a map, int, okay, called a counter, and then actually I don't know what's the API for map. Update insert. Iterate the map. Const auto this. Okay, so I need to get a map. Alright, now what? Then everyone we can say for int n of nums, and then for all the keys. Oh, I can do this. Auto const key. I don't need a value of counter. Alright, so for each one we say counter key plus, nope, counter key plus n. Oh, is that default value? I'm not sure. Find key. Check key map. Contains. Okay, then we say if counter dot contains k plus v, no, k plus n. Alright, and then we say counter k plus n plus plus, else counter k plus n to 1. And now we do exactly the same. Say k minus n, right? Because you can do plus, you can of course do minus. So for each n we go through whatever, and then at the end we return if counter dot contains target, return counter target, and also return 0. Okay, I'm not sure. This one is just put together. Okay, that is not right. Because the first one, okay, so count to 0 has to equal to 1, right? You have to count the 0, and then the first one you can do plus and minus. Ooh. Okay, that's still not right. Okay, this is another idea, is we do half and half. We cut it in half. We do the first half, okay, and we do the second half, because when we have, we can divide the whole complexity by 2, and then it's just going to be a matching. Okay, so we're just going to be matching. So this one will be similar to this. Let's hope that this one will work. Otherwise, man, otherwise it'll be very sad. It's gonna be a sad Christmas. Alright, so actually this is gonna be solution 2, because the solution 2 doesn't really work. Screw solution 2. Alright, so this will be the same. We do a mask, yes, but we don't go through the whole thing. Right, we don't go through the whole thing. Oof, that's a range. Start. Okay. Hold on. We got a mask, and then this one we need to have low and high. Okay, sum is 0. This is not true. I go to low, I smaller equal to high. Okay, every single one. And then on the mask. On the mask. Oh Lord. On the mask. So what low represents and what a high represents, right? So on the mask is just the size. So it's going to be high minus low plus 1 minus 1, so I can just remove that, right? High minus low minus I. So if we start I is a low, right? If I is low, so as I say I is 0, I is in minus 1. So we're gonna go, that's not right, because mask is not the same size as nums. Mask is a different size, right? Mask is a different size. So it's actually going to be easier if we go through mask. Yeah, because low and high, hold on, low and high is, low is going to be 0, high is going to be n divided by 2, right? I think this might actually work, because low minus high plus 1 is the size of mask, right? That's the size of mask. So low minus high, high minus low is size of mask minus 1. And then this one minus I. Yes, I think this one's actually right. Okay, so so I still think this is still true, but we'll do the brute force for half of nums, then match the other half for target. Right, this is fine. Total possibilities is going to be n divided by 2. Actually, I'm not sure. It's an integer division, or m divided by 2, right? And length, left length and right length. Left size is n divided by 2. Right size should be n minus left size. Okay. And then for this possibilities, left possibilities is left size. Okay. And then the left possibilities, we of course has a map so left counter, okay, sum is equal to compute is the mask is nums, so low gonna be 0, high is going to be left size minus 1, that's the high, right? So I have a low and a high, and we say if left counter dot contains sum. Oh, I guess I can just say left counter sum plus plus. Right, and then for int I equal to left position I smaller than n plus sum is equal to compute I, oh, that's not right. This shall be 1 left shift n, and this is left possibilities. Yeah, left possibilities, and this is the total possibilities. So we're going through the remainder, right? So I have nums and low. It's all possibilities on the right hand side. And low shall be left size and -1. I don't think we need the right size. So basically, yeah, we got a sum which is on the right hand side. So we want to see so it's gonna be the left minus this, so it's just gonna be the, okay, so we're gonna have int res, oh, res I already defined. So if target plus sum, so the left minus, hold a second, because I use, it's all possibility, right? All combinations. That's actually not right. That's actually not right. All combinations on the right hand side. I do need a right size and minus left size, right? So I have the left position and the right possibility should become a left right size, okay? And this is still 0. This shall be right possibility in each one, but this is different from left side to this, okay? So now we got a sum, and basically it's the left plus this right sum should equal the target. So it should be target minus this, right? So I can say temp equal to target minus this. Okay, that's not right. No, that is right. That is right. Right, temp shall equal to target minus this. So if left counter, I can just say res plus equal to left counter temp. Alright, no matter how many it is. Okay. Let's try this. Alright, if this doesn't work, then I am going to -1. So I is low to high, right? I is this, and so shall be I minus low. I minus low. So this should be minus I plus low. It should be high minus I. All right. Oh, this looks promising. Actually, we should do all of them. Plus this. Nice. Try it. Hey, Merry Christmas, everyone. We got it. I think we did better than last time. I'm pretty sure last time I have to resort to the solution, but this time we got it. Just do half. Just do half. Alright? We can use the two-sum technique for this. Oh boy, that one took a while, but we got it. Brute force. But I think the brute force is working, huh? I have DP. Ooh. Alright. Man. I have to leave this for further reading again. God lord. You're just gonna pile this up, man. But, you know, when a problem took this long, it's usually... Alright, I have to... See you guys tomorrow. I don't want to do it again. I'll see you guys tomorrow.